Okay, this is a true story about a mountain and a cloud and a radar and an airplane and a snow gauge. And this story begins in Idaho on January 19th, 2017, when a cloud was heading toward Packer John Mountain. A nearby radar was ready, and it took a picture of this cloud. And when it took a picture of the cloud, the radar could see that the cloud didn't have very much water in it at all. And then an airplane took off ahead of the cloud, and right when it got ahead of the cloud, it dropped some magic dust into the cloud. It dropped silver iodide into the cloud. And then the radar took another picture, and the cloud had changed. It was more reflective to the radar. It had more water in it. And there were some other clouds in the sky, but the airplane only gave the silver iodide to one of those clouds, and this created a line. As more clouds appeared, the radar kept tracking them and taking pictures of them. The one with the silver iodide in it still looked different on the radar picture. And as the clouds got closer to the mountain, there was a little snow gauge that started getting ready. The radar kept tracking the clouds and tracking the time. And then right when the cloud that got the magical dust approached the mountain, it got blown higher into the air. It started getting colder. The cloud began to release snow. And the rain gauge caught some of this snow. Then these other clouds right behind it, and they were also lifted over the mountain in the same way. And they also got cold in the same way, but they didn't release hardly any snow at all. And then they did this over the next few days. And the clouds that got the silver iodide usually rained on the mountain, and the clouds that didn't get the silver iodide didn't rain on the mountain. And of course, this was all being tracked by the radar. The results, which were published in a peer-reviewed journal, were a critical step toward quantifying the spatial and temporal evolution of cloud seeding impacts, but questions remain on a variety of atmospheric variables that control microphysical and dynamical processes in clouds and precipitation effects. And that's the end.